Hello, welcome back to another math video. Today we are going to talk about multiplying and dividing rational expressions. So to start, let us try to review first concepts about multiplying and dividing fractions. So for instance, we are given the fraction 5 thirds times 2 thirds. When we multiply fractions, all we have to do is simply multiply the numerator and then multiply the denominator. So in this example, we have 5 times 2 will give us 10, and then 3 times 3 will give us 9. So this will be our final answer. Next, we have 8 over 14 times 7 over 12. So again, multiply the numerator and then multiply the denominator. So in this example, we have 8 times 7 will give us 56, and then 14 times 12 will give us 168. And then we are going to simplify our answers. So 56 over 168 is just equal to 1 over 3. Next, what if we are to divide fractions? For instance, we have 5 over 2 divided by 2 thirds. So when we are dividing fractions, first we are going to get the reciprocal of our divisor and then proceed to multiplication. So in this example, this is our divisor, 2 thirds. So what we are going to do is get the reciprocal of 2 thirds, that is equal to 3 over 2, and then again proceed to multiplication. So we have 5 times 3 will give us 15, and then 2 times 2 will give us 4. Therefore, when we divide 5 over 2 divided by 2 thirds, that will give us 15 over 4. Now, let's try to apply the concepts or the idea when dividing fractions in dividing or multiplying rational expressions. So, for example, a to the fifth power over 10 multiplied to 5 over a cubed. So again, the same concepts, multiply the numerator and then multiply the denominator. So we have a to the fifth power times 5 will give us 5 a to the fifth power, and then 10 times a cube will give us 10 a cube. And then we are going to simplify 5 a to the fifth power can be written as 5 times a times a times a times a times a, while 10 to and a cube can be written as 2 times 5 times a times a times a. Now, if we're going to look at our numerator and denominator, we can find common numbers. So for instance, we have here 5. So we're going to cancel out 5. We have a and a. We also have another a and another a. And we have a and a. We don't have 2 in our numerator, so the remaining numbers are the following. So we have a times a, and then in our denominator we have 2. So our final answer should be a times a will give us a squared and then over 2. So therefore, when we multiply a to the fifth power over 10 times 5 over a cubed, that will give us a squared over 2. Next example, 30b squared over 6c times 4c squared over 15b to the fourth power. So again, what we're going to do is we are going to multiply the numerator and then the denominator. So in this example, 30 times 4 will give us 120, and then b squared times c squared is just b squared c squared. And then in our denominator, 6 times 15 will give us 90, and then b to the fourth power, and then c. And the same thing earlier, we're going to find common factors from the numerator and denominator. So 120 can be written as, where is it? Can be written as 4 times 30, and then b squared is just b times b, c squared is c times c. Then again, 90 can be written as 30 times 3, and then b to the fourth power is equal to b times b times b times b, and then c. The same thing earlier, we're going to find or cancel out common factors. So in our numerator, we have 30. We also have 30 in our denominators. We're going to cancel that one out. We have b. We have also b in the denominator. We have b, b, and then c, and then we have c. Now, what is left in our denominator is we have 3 and we have b times b. In our numerator, we have 4 and then we have c. Therefore, our final answer will be 4c over 3b squared. So again, when we multiply 30b squared over 6c times 4c squared over 15b to the fourth power, that will give us 4c over 3b squared. So again, this is one way of multiplying a rational expression. Now, allow me to present another way in multiplying rational expressions using the same examples. So in our example 1, we actually use this rational expression. So we multiplied a to the fifth power over 10 times 5 over a cube. Now, what we can do here is actually, before even multiplying, we can now cancel out common factors. So for example, we all know that a to the fifth power is just equal to a squared times a, sorry for the penmanship, I'm just using my mouse pad. So again, a to the fifth power can be rewritten as a squared minus a squared times a cube. So therefore, from here, we can now actually cancel out a cube. And then again, our 10 can be rewritten as 2 times 5. So we are going to cancel this one out. What will remain now is 2. So in our numerator, we will have a squared, and then in our denominator, we have 2. So therefore, our answer now is a squared over 2, which is again the same with our answer earlier. Next example. Again, this is the example earlier. So we have 30b squared over 6c times 4c squared over 15b to the fourth power. And again, 30 divided by 6 is actually 5. So we're going to cancel this one out. This will become 1. And then this will become 5. Right? Now, also, we have here 15 and then 5. We have 15 and then we have 5. If we are going to get the factors of 15, 15 can be rewritten as 3 times 5. So therefore, we can actually cancel this one out. That will become 1, and then 15 will become 3 already. And then we have b squared, and then we have b to the fourth power. Again, b to the fourth power is just equal to b squared times b squared. So we can cancel this one out. And then, this will become b squared. Again, I am just using or applying the rule of exponents. And then, we also have c. C squared is just c times c. So we can actually cancel this one out. And then what will remain is just c. Alright, so again, in our numerator, what we have here is, let me just highlight this one. We have 4, and then we also have c. And then in our denominator, we have what? 3, and then we have b squared. So our final answer will be 4 4c over 3b squared, which is again the same with what with our answer earlier. This is a bit complex for some, but then again, this will save us in simplifying big numbers, because again, before we even multiply, we actually simplify our answers. But then again, if you find this a bit hard, you can actually follow the first method presented earlier. So let's proceed now to before that. Let's have this one more example. So multiply 3d over 3f minus 12 times 4f minus 16 over 12d squared. Now again, what we can do actually is, if we are going to look at our 4f minus 16, we can actually factor out 4, and then once we do that, this is actually equal to 4, and then what will remain is f minus 4. Alright, so 4 times f is 4f, 4 times negative 4 is negative 16. The same thing can be applied in our denominator. So this can be factored out as 3. And then what will remain is just f minus 4. Where is it? Alright, that's 4. And here, we can actually factor out what? 3d actually. So this is just equal to 3d. 3d times what? We have 4d, right? So you have 4 and we have d. So 3d times 4d is just 12d squared. Now, if we're going to look at our rational expressions, actually, we can now cancel out 4, f minus 4. Cancel this one out. We can also cancel out our 3d and our 3d. Now, in our denominator, we have 3, and then we have 4d. In our numerator, we have 4. Alright, and again, this is 1. But notice that we also have 4 here. Remember that 4d can be rewritten as 4 times d. So basically, we can cancel this out further. This will be cancelled out, and then this will be cancelled out. And what will remain is actually 1. So in our numerator, we have 1 times 1. That will give us 1. And then in our denominator, we have 3. and then we have d, so 3 times d is just equal to 3d. So therefore, when we multiply 3d over 3f minus 12 times 4f minus 16 over 12d squared, that will give us 1 over 3d. So again, this is the beauty of canceling or using the cancellation method when multiplying rational expressions. But then again, if you are not comfortable using this method, you can actually again go back to the first method mentioned earlier. Last one, we have division, dividing rational expression. So we have 8 over um, 56r minus 48 divided by 1 over 42r squared minus 36r. Again, remember earlier when we divide fractions, we are going to get the reciprocal of the divisor and proceed to multiplication. So in this example, again, we are going to get first the reciprocal of our divisor. So let's do that. So this will become 8 over 56r minus 48. Reciprocal of this one is just equal to 42r squared minus 36r over 1. So no need for us to write 1. And again, we are going to make use of the cancellation method. So we're going to factor out common terms from both numerator and denominator. So 56r minus 48 can be rewritten as 8 times 7r minus 6, and then the same is true with our 42r squared minus 36r. We can actually factor out 6r, and then what will remain is 7r minus 6. And again, we have now common, and then we have now common, and then we have also 8, and we have 8. So what is actually left is 6r. And again, that will be our final answer. Next example. Divide x plus 1 over 4x by x plus 1 over 48x. Again, first thing to do is get the reciprocal of our divisor. So this will become 7, x plus 1 over 4x times the reciprocal of this one is just equal to 48x over x plus 1. And if you notice here, we actually have common factors already. So we have x plus 1, then we have x plus 1. And 48x can be factored out, can be rewritten as 4x times 12. And again, we have 4x, we have 4x. So what is left is just 12. So therefore, x plus 1 over 4x divided by x plus 1 over 48x is just equal to 12.